The circuit diagram shows a circuit consisting of a battery of how do you say negligible, something like negligible resistance, two emitters also of negligible resistance, three resistors of and two high resistance voltmeters. The reading on emitter one is 1 amp.
Okay, thank you so much, sir. So the circuit diagram shows a circuit consisting of a battery of negligible resistance, two ammeters also of negligible resistance, three resistors, and two high resistance voltmeters. The reading on ammeter A1 is 1 ampere. Okay, fine. So yes, this is what we can see. V3 is the potential difference across the battery, and the battery has 3 cells. V1 is the potential difference across the single resistor connected in series, and V2 is the potential difference across two resistors connected in parallel, yes? And of course, we have two ammeters there. Ammeter A1 is measuring the current through the 6 ohm resistor only, and ammeter A2 is measuring the total current in the circuit. This situation looks very familiar. Have we not done this before? But let's do it anyway. It really looks familiar. Okay. Now, this is the first question. The first question says, complete the following statement by filling in the missing words. Resistors in series divide what? And resistors in parallel divide what? Well, you got this one right. So in series, they divide the potential difference, and in parallel, they divide the current strength. You can say the current or the electric current. Well, it's still fine. And now the question is saying calculate the effective resistance of the parallel combination of the resistors. Okay, so the resistance in parallel, that is to say. And then the next question is saying calculate the total resistance. Let's destroy those two questions first. So, well, we can see we have two resistors in parallel, the 6 ohm and the 12 ohm resistor. So let's go and do the thing. So this is how we do the thing. How do we do it anyway? We know we have two ways of calculating the resistance in parallel, and we are going to use both of those ways. The first way is the one that I like because I was taught this by my favorite teacher. That's why I still remember it. And this is what he said. He said the resistance in parallel is given by the product of the two resistors divided by the sum of the two resistors. And by the way, I don't recommend having a favorite teacher because then you'll only love the subject of that teacher and neglect other subjects. So if you were to have favorites, well, make sure that every teacher is your favorite. That way you won't be biased and you love all the subjects, yes? The resistor R1 will say it's 6 ohm, R2 is 12 ohm, and we divide this by the sum of the two resistors. And if I now go to my calculator, which was given to me back in 2019, and I press this, I find that the resistance in parallel will be 4 ohms. All right. But of course, if I feel like saying this is too much, then I could have just used the formula that says the following. The original formula I should add. It's the one you will find in the formula sheet. This one, you won't really find it in the formula sheet, no? No. And remember, this one only works for 2 resistors. If you have 3 resistors, it won't work. It's going to give you incorrect results. So keep that in mind. So now we come and say we have 1 over 6 here, which is added to 1 over 12. And you can now go to your nice calculator and say, what is 1 over 6 plus 1 over 12? And you are simply going to get 1 over 4. That's what you're going to get. Then the next step is to reciprocate, because you're not looking for 1 over RP, you're looking for RP. Take the numerator into the denominator and take the denominator into the numerator. And now you will find that your RP will simply be that much. It will be 4 ohm. That is your resistance in parallel. Now that we know the resistance in parallel, then we can find the total resistance. In order to find the total resistance, we take the resistance of those in series, we add it to the resistance of those in parallel. We only have one resistor in series, and that is the 18 ohm resistor. And those in parallel, we have the 4 ohm resistor. And if we add those two up, we simply get 22 ohms. And this is the total resistance of the circuit. So then the next question is saying, calculate the amount of charge passing through the ammeter A2 in 5 seconds. Well, that's what they say. The amount of charge passing through the ammeter A2. And if you look at this ammeter A2, it's the one that measures the total current. Well, that's what they say to us. So in simpler terms, the question here is asking us to find the total current. That's what the question is saying. So that once we know the total current, then it will be easy to find the amount of charge passing through the ammeter A2. But now this is the thing. We don't know the total potential difference of the battery. No? But they gave us the reading on ammeter A1. So we can use that to find the potential difference of those in yes, we can use that to find the potential difference of those in parallel. Or we don't need to find the potential difference of those in parallel. That's actually a long walk to freedom. So what we can use is we can move backwards. How? We know that if we wanted to find the current, if we wanted to find the current that passes through the 6 ohm resistor, we've seen it in the lesson already. We said, well, we are going to take the 12 ohm resistor and put it in the numerator, divide that by the total, which is 18, and multiply that with the total current. That's what we said, right? Yes. In order to find the current that passes through the 6 ohm, we can reverse that and use that knowledge in order to find the total current. I'm not sure if you get what I mean, but let me elaborate. Some things you need to see them in order to understand them. This is what I'm saying. If we wanted to find the current through the 6 ohm resistor, which is the top resistor in parallel, this is how we could have found it. We could have taken the 12 ohm resistor, which is the resistor that's below in the parallel combination, and we divide this by the sum of those two resistors in parallel, and we multiply this by the total current. We could have done that. But now we know the current that passes through the 6 ohm resistor is 1 ampere. So this means we just need to divide both sides by the thing, 12 over 18. And when you say 1 divided by 12 over 18, it's the same as 1 multiplied by 18 over 12, which means that the total current will be 1.5 amperes. This was the quickest way to get it. But let's also consider the much longer way of getting it in case you don't think this or think like this in the exam. I wanted to say that. So we could have found the potential difference across the 6 ohm resistor, but then how will it help us? Now this is what I'm going to say, which I did say to you. I'm not sure if you are still comfortable with that, but listen to this. We can find the potential difference across the 6 ohm resistor, which we will get to be 6 volts. Now listen, that potential difference across the 6 ohm is the same as the potential difference across the 12 ohm, because in parallel, the potential difference remains constant. This is the part that may confuse you. Listen closely. That potential difference is going to be exactly the same as the potential difference across a single resistor that represents the two resistors in parallel. Do you get it? And we have found this resistor already. We got it as 4 ohm. The resistance in parallel. It's a single resistor that represents the two resistors in parallel. So now that we have a single resistor that represents those two in parallel, and we know the potential difference across the parallel combination, then we can find the current that passes through the single resistor, which represents those two in parallel. Let's go. This is what I'm saying. So I'll just cover this up. I'm saying the first thing we'll have to do is to find the potential difference across the 6 ohm resistor using Ohm's law. R equals V over I. Very well. Now we say the resistance of the resistor is 6 ohm. We are looking for the potential difference, but we know the current that passes through the thing is 1 ohm, which means that the potential difference across the 6 ohm will be 6 volts. Okay. Then what is the next thing we need to do? The next thing we need to do now is to find the current that passes through a single resistor, which represents those two in parallel. We are still going to state Ohm's law. That's true. And now we say, well, the single resistor is 4 ohm, and it's also going to experience a potential difference of 6 volts. We are looking for the current that passes through it. If you want to make the denominator to become the subject, you just take it and make it the subject, and take what was already the subject and make it the denominator. And when you say 6 divided by 4, it's exactly the same as saying 3 divided by 2, which is 1.5. In case you didn't think this way, but that was the quickest way out, it helps to have options. All right. Now then, we have found our thing, the current, I mean. So now we can easily find the amount of charge by going to the definition of current and saying current is defined as the rate of flow of charge. So we know the current is 1.5 amperes. We are looking for the amount of charge that flows in 5 seconds, they said. And now we can cross multiply, and we find that we have 7.5 coulomb of charge that passes through the thing in 5 seconds. Okay, now listen. They say, how does the potential difference across the 6 ohm resistor compare to the potential difference across the 12 ohm resistor? Write down less than, greater than, or equal to. Well, the answer is equal to. Why equal to? Because the potential difference across the resistors connected in parallel remains constant. Or you can say is the same. That's the reason. It's not a complicated reason, but yeah, it's not a complicated reason. No. In parallel, the potential difference remains constant. That's just it. And lastly, they say, if the 6 ohm resistor bends out, Will the total resistance of the circuit increase, decrease, or remain the same? And the answer is increase. Because when you're saying it bends out, you mean it's not working anymore. So it's like, it's not there anymore. So if the 6 ohm resistor is no longer there, then there won't be current flowing through the 6 ohm resistor. It means current will flow from the positive terminal of the battery, flow through the 18 ohm resistor, and flow through the 12 ohm resistor, and go back to the battery. Which means that the circuit is now connected in series. And resistors in series, they increase the total resistance. That's the reason why. If you remove the 6 ohm resistor, the circuit is now connected in series. And resistors in series increase the total resistance.